In this video series, I work through a math problem or problems each video. We can graph the solutions to equations with absolute value symbols in a way similar to how we have been graphing the solutions to linear equations. If we have only one linear variable in the equation, we get either 0, 1, or 2 solutions. When we graph this solution or solutions on a number line, we get 0, 1, or 2 points. When we graph the solution in a coordinate plane, the points turn into vertical lines. If we graph an equation that is linear in one variable and the other linear variable is written inside of the absolute value symbols, we get a V-shaped graph in a coordinate plane. Let's take a look at examples. Graph the following equations with absolute values. The absolute value of x is equal to 4. Since 4 is a number bigger than 0, we can remove the absolute value symbol from x and set it equal to the plus and minus of this number. So the solution to this equation, or the solutions to this equation, are 4 and minus 4. So if this is a number line, we can graph the points minus 4 and 4. And these are the solutions to this equation graphed on this number line. If we want to graph the solutions on a coordinate plane, then these points turn into vertical lines, since any point on the same vertical line share the same x-coordinate. Next, we have the equation y is equal to the absolute value of 3x plus 2. If we take a look at the expression 3x that is inside the absolute value, then we know that if 3x is positive or 0, we can just go ahead and remove the absolute value sign. In that case, we get the equation y is equal to 3x plus 2. But if the quantity 3x were negative, then we have to change the number that's negative to positive, which means we have to put a minus sign in front of it, which changes that number to a positive number. These two lines intersect at 0, 2 because both of these lines have the same y-intercept of 2. So if we graph these two equations, we get two intersecting lines that look like an X intersecting at 0, 2. And the equation for the y is equal to the absolute value of 3x plus 2 is some part of that x. So let's try to figure out which part of the two graphs are also part of this graph. If we take a closer look at the expression here once again, the absolute value of 3x, then first of all, we need to determine when this quantity is positive or 0 or bigger than 0. And if we think about it, if we plug in any number that's bigger than 0, so any positive number or 0 here, 3 multiplied by 0 is 0, and 3 multiplied by a positive number is positive. So this quantity will end up being positive if the number that we plug in is bigger than or equal to 0. So we take the part of this graph that's bigger than or equal to 0. So essentially the right part of this graph. And when is the quantity 3x negative? If we plug in a negative number for x, positive multiplied by a negative number is a negative number. So since we have to change the sign when x is negative, we take the part of this graph when x is less than 0. Okay, so let's go ahead and graph these equations with these restrictions. The equation y is equal to minus 3x plus 2 for x is less than 0, and the graph y is equal to 3x plus 2 for x is greater than or equal to 0. So if we graph this equation, we know that the y-intercept of this equation is 2, and the slope is 3, which means if we go to the right by 1 unit, we need to go up 3 units. And once again, we go to the right by 1, and up 3, and one more. To the right by 1, and up 3. Next, if we take a look at this equation, y is equal to minus 3x plus 2, once again, this graph starts at the same point, 0, 2, but since the slope is minus 3, if we go to the left by 1 unit, we need to go up by 3 units. So 1, 2, 3, to the left by 1, and up 3, 1, 2, 3, and one more. To the left by 1, then 1, 2, 3. Now we connect the dots to complete this graph. And as discussed before, the graph of this equation with a linear variable on one side of the equation and another linear variable inside of the absolute value symbols is a V-shaped graph.